Here we have y equal 2 secant quantity 1/2 x minus 3. We're interested in finding out its period and where its asymptotes are. So first of all, secant's the reciprocal of cosine, so we'll have the same period as cosine. Cosine period is 2 pi, but then divided by what's sitting out in front of the x. So this period is going to be 4 pi. Now let's look at a basic secant graph and notice some things about its asymptotes. And so here is just a secant x graph. It has a vertical asymptote at pi over 2 and another one at 3 pi over 2, and then obviously keeps going in both directions. So if I looked at starting at 0, the period of this is 2 pi. So within that period there are two asymptotes, and we notice that the asymptotes are pi apart, which basically is half of the period. Now the first asymptote, because the secant graph is based on what the cosine does, and the cosine typically starts at its maximum, and then in the first fourth it equals 0, that's where the vertical asymptote is. So that first asymptote is 1/4 of the way through the period if you started out at the maximum. And so we're going to utilize those things as we go figure out where the asymptotes are on for the equation that we have. And I'm not going to do a phase shift yet. I'm just going to figure this out without the phase shift, and then we will apply the phase shift. So first of all, without the phase shift, at 0 the cosine is at its maximum, and so this will be a point, and then the secant will take off, from there. So as we figure out where the first asymptote is, the period is 4 pi. So it's not going to repeat itself till we get clear over here to 4 pi, and the first asymptote is 1/4 of the way through the period. Well, 4 pi divided by 4 is pi, so the first asymptote is going to be here at pi. Now that's without the phase shift. And then the asymptotes would be half of a period apart, because in our normal secant graph it was 2 pi for the period, and we saw these asymptotes are half of that, or pi apart. So our asymptotes are going to be 2 pi apart. So there would be another asymptote over here at 3 pi, which is 2 pi away, and then another one over here at 5 pi, and they would keep going every 2 pi apart. Now let's look at the shift. Well, we have 1/2 x minus 3 pi equals 0. So 1/2 x equals 3 pi, and x is 6 pi. So our asymptotes are going to be slid to the right by 6 pi. Now that's going to be off my picture because the first one was at pi, and we need to add 6 pi to that to get where that is once it's transformed. So it's going to be at 7 pi. Now I can put that right here because the question always asks, it normally would have started where the first asymptote was, but then with the phase shift, where's it going to be? So that's going to be at 7 pi, and then these asymptotes are half of a period apart, so we're going to add half periods here, which is going to be 2 pi. Now, to decide where that was, then I would pick this pi one up and have it land over here on 7 pi, but you can see these asymptotes are all at multiples, odd multiples of pi, so they're still going to look like this in my graph because these are just some that got shifted over 6 pi, and so this particular one that's shown right here would have been at -5 pi, and then when I move it to the right by 6 pi, it lands here at pi. So my graph is going to have this maximum and head towards the asymptote. No, wait, I better figure out whether it'll be at a max or whether it'll be a min after everything got shifted. So normally this would have been right here, and it's going to be shifted to the right by 6 pi. So it would land right there. And so actually this one is going to be up then. So this one is going to be down, and this one is going to be up. So this one is actually going to be down with that phase shift.